Hello there and welcome to the series of videos going through the content of A-Level Further Maths. Here we're looking at how we can perform linear transformations in 3 dimensions working on an x, y, z axis so we can answer questions from exercise 7e. So just a little bit of notation first. This is how we're going to be drawing our set of axes. We've got x going along the bottom, downwards to the bottom right hand corner. Y is going perpendicular to it. This will be a right angle here towards the top right hand corner of the screen, and the z-axis will be going vertically upwards. Okay, so you can imagine yourself looking down upon your sheet of paper that's on the table down here, and you will see your xy axis. So when you're looking down at your sheet of paper, just imagine that the z-axis is coming straight back up at you. A little bit of terminology before we get started. The zy plane represents all of the coordinates that are going through the z and the y-axis here. So this plane here, we're calling it a plane, and that just means basically a sheet of paper that's in 3 dimensions, goes through the z-axis and through the y-axis. So all of these points here, 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 and here are on this plane. There's no dimension for the x-axis, so what we can say here is that this is the x equals 0 plane. It's probably a nicer definition. Very similarly, the xz plane will be going through the x and the z dimensions on axes, so there's no dimension going into the y-axis. It's like a sheet of paper where the y-axis will completely chop it through the middle. So this is the y equals 0 plane. There are all of the coordinates on this plane here are where y equals 0. And the same for the z equals 0 plane. It's the xy plane. It just is a sheet of paper on the table, and all of the z coordinates on this sheet of paper here have a z coordinate of 0. It doesn't go up or down by anything. Okay, so that's we'll come back to this in a bit, because what we're going to be doing is we're going to be reflecting coordinates through different types of planes like this. I'm also going to be looking at rotation as well, but to start off with, we're going to be looking at reflection. So just a note on different types of axes that you may see, we're going to be working with right-hand coordinates in this video. Okay, we're going to keep to the same standard of same standard of axes. You may see it sometimes written as left-hand coordinates like this in different videos and maybe in different textbooks, but for the benefit of this video, we're going to stick with right-hand coordinates. So what do I mean right-hand coordinates? Well, if you were to hold your hand up in front of you now, stick outwards, stick up your index finger, stick out your thumb naturally, the way that it extends outwards, and then put your middle finger going forwards, and then going from thumb, index finger, middle finger, that's your x, y, and z axis. What I would do actually is I would rest your hand on the table so that you've got your x axis going to the right, your y axis going forward in front of you, and then the z axis coming out of the table vertically upwards. So it's a better way of representing the vectors if you lay your hand onto the table and do this funny symbol here. If you're seen doing this in an exam, other people should know what you're doing. Okay, so what we're going to look at here is a question. A transformation U in 3 dimensions represents a reflection in the z equals 0 plane. Okay, and the question is, write down the 3 by 3 matrix that represents this transformation, and then afterwards we want to find the image of some point. So this is the z equals 0 plane. It's basically a sheet of paper that covers the x and the y axes. So we're going to have 3 base coordinates. Remember when we did this before in 2 dimensions, we had 2 base coordinates, 1, 0 and 0, 1. In this case here we need 3 base coordinates, 1, 0, 0, 0, 1, 0 and 0, 0, 1. When we reflect in this z equals 0 plane, it's going to be the green coordinate that reflects downwards onto the bottom underneath this sheet of paper. So our original coordinates go into the columns in their order, okay, in the order that it will make an identity matrix. Okay, so 1, 0, 0, 0, 1, 0 and 0, 0, 1. So put them in order. And then after you've done the reflection, the green coordinate will go from the top to the bottom. Okay, it will go down to there. This coordinate here, if it's been reflected and it's on the line of reflection, it doesn't move. As with the red coordinate, it's on the line of reflection, so this coordinate doesn't move either. So the new set of coordinates, the red one stayed the same, the blue one stayed the same, and the green one has reflected down to 0, 0, -1. You've got to make sure that you put corresponding coordinates into the correct columns as they go in. So you see, so earlier here, it went blue, so it went red, blue, green, and in this case here it's going to go again, red, blue, green. So here we've got some matrix M that we want to find out that transformed our base set of coordinates to this set of coordinates here. Well, given that this identity matrix is just the identity matrix, we can kind of just delete it because it's effectively times in by 1, and our answer here is this new set of coordinates here, 1, 0, 0, 0, 1, 0, 0, 0, 1, -1. Okay, so that is the matrix that will reflect in the z equals 0 plane. And you may start to memorize these types of reflection in z equals 0 planes or xy planes. It's the z dimension here that's got a -1 in it that's going to reflect it. And you can imagine if it was reflecting in the x equals 0 plane, this -1 would still be a 1 because that won't reflect, but it would be the top left-hand cell where the x-axis is. That would be where the -1 is. So if you want to reflect in a letter equals 0 plane, you set that letter equal to -1 and the other two can stay as 1. Okay, so it's a nice little shortcut there. Find the image of this set of coordinates. So pretty standard question, you just take your transformation matrix, multiply it by your coordinate, multiply out the brackets, and you should see that the two coordinates on the top stay the same, and it's only the z coordinate that reflects over. Okay, so in general, this is how it's going to go. If you're reflecting in the x equals 0 plane, you've got a -1 in the top left. If you're reflecting in the y equals 0 plane, you've got a -1 in the middle. If you're reflecting in the z equals 0 plane, you've got a -1 in the z position. Okay, so you probably could remember those without having to work through the maths that we did earlier and drawing out all the base coordinates, reflecting one of the coordinates and then writing out blah blah blah. You can probably just remember these. Okay, slightly more difficult questions though come with transformations. So in this transformation here, U is a 3-dimensional transformation representing 90 degrees anti-clockwise around the x-axis. So take your x-axis as your center of rotation, and it's going to rotate around that axis there. The question is, write down this 3×3 matrix and find the image of the point -1, 2, 3. Okay, so what we can do here is, given that the x-axis is our center of rotation, nothing is going to happen to any of the coordinates along this x-axis, because it's only the y and the z coordinates that are going to be rotated around this x-axis that are going to be changed. So we can already identify 5 of the values in this matrix here to reflect around the x-axis. It's very similar to if we were reflecting around the y-axis, it would be 0, 1, 0, 0, 1, 0 in the y coordinate parts of the matrix. And if we were rotating around the z-axis, it would be 0, 1, 0, 0, 1, 0, 0, where the z-axis is in our matrix here. So because we are reflecting around the x-axis, we have pre-filled in these cells here. The x-axis won't change, so we need zeros and zeros in the other corresponding cells on the x-axis, and 1 to be on the xx point in our matrix. Okay, so given that we now know that we're reflecting from the x-axis, let's create a little person that's looking towards our our z and our y-axis. And what does this person see? Well, this person sees the y-axis on the right and the z-axis going upwards. So that's how we're going to draw our axes. And we're going to now simplify this problem to this little person standing where the x-coordinate is, where the x label is, and they're seeing it from a two-dimensional point of view now. So imagine you're this little person. You can only now really see the y-axis that's going from left to right and the z-axis that's going horizontally up, so vertically upwards. And this is what you would see if you're this little person. Okay. And we're looking to take the base coordinates. Now this base coordinate here is actually representing y coordinate of 1, z coordinate of 0, y coordinate of 0, and z coordinate of 1. So it's now a yz coordinate. And we are asked to rotate this 90 degrees anti-clockwise, so that's going around that way. So where will these coordinates end up? Well, the red coordinate will end up at the y coordinate 0, z coordinate 1, and the blue coordinate would end up around here. So there's been some matrix that times these base coordinates to get to these image coordinates. So this matrix has times our base coordinates to get to this image coordinates. But handily, this base coordinate here is just the matrix 1, or the identity matrix, so we can effectively just scribble it out, and the matrix that has performed this transformation is this matrix here. 0, -1, 1, 0. So this is the 2 by 2 matrix that will that will rotate anti-clockwise around the YZ dimensions. So all that's left for us to do now is just pop this 2 by 2 matrix into the gap in our matrix over here, and that's our final answer. So that's all we have to remember to do for rotating in 3 dimensions. Okay, we we set up the 1s and 0s along the axis that we are rotating around. We imagine that we're a little person standing by the label for that axis, looking at the problem from now just 2 dimensions. Draw out your question in 2 dimensions. Do your rotation with your base coordinates. Always pick 1, 0 and 0, 1. And then think about, well, these image coordinates are actually the final matrix that has performed that transformation. And then just bung that final matrix into the remaining 4 cells that you'll have left in your matrix. So this is our final answer. Another way of seeing it in 3 dimensions, which is slightly harder to visualize, but we'll give it a go anyway, is if we're reflecting around the x-axis, then we'll have these as our original coordinates. We're now going to rotate the blue one around to this z-axis, still imagining you're the person standing next to this x-axis label, looking at it from this direction. Then the green coordinate 0, 0, 1 will rotate round onto the y-axis. So you'll end up with coordinates in these positions here. So our new set of coordinates, the 1, 0, 0 hasn't changed because it hasn't rotated around anything. It's on the line of rotation, so it doesn't move. Then it's 0, 0, 1, and it's 0, -1, 0. And that is exactly the same answer as we had before. Okay, so you can imagine it in 3 dimensions if you feel confident in doing that, but I'd much rather work back in 2 dimensions. Find the image of this set of coordinate. Well, that's easy. You just times the transformation matrix by the coordinate, and you get your answer, -1, 3, -2. Okay, we're going to have a go at this one now, where we've got the matrix, and we need to work out the type of rotation that we're going to have in this matrix here. Now, we know it's not going to be reflection. Reflection just has 1s in the leading diagonals with a -1 in one of those positions. So we know it's definitely going to be a rotation. So the questions here are describe the transformation and reflect this coordinate and perform transformation on this coordinate. Now, immediately I can see that if I were to delete the y-axis in both horizontal and vertical directions, what's going to happen here is that the y-axis is not going to change. None of the y coordinates are going to be moving. So I can immediately identify from looking at which column and vertical and row I can delete that is that's the axis of rotation that I'm going to be rotating around. So in this case here, I definitely know that I'm going to be rotating around the y-axis. If there were just zeros and ones in this z-axis, I'd know that I'd be rotating around the z-axis. Now the y-axis is a little bit more of a fiddly one. Let's imagine we are the same person just standing next to the y label and looking back at the problem here. What would we see? Well, we'd actually see the x-axis on the left and the z-axis on the right. Sorry, going vertically upwards rather. So x-axis on the left, z-axis going vertically upwards. So actually, it doesn't look quite right, but this is how our axes are going to look really. It's going to be x going to the left and z going upwards. And this is going to be left is now positive direction. So this phenomenon only happens with the y-axis if you're rotating around the y-axis. Z-axis is fine, it's normal x, y coordinates like you know them. In the y-axis, it's x going this way and z going upwards. And yeah, it looks pretty strange to put the positive 1, 0 coordinate on the left, but that's where it's going to go. The positive x-axis coordinates are on the left, and the positive z coordinates are still going vertically upwards. So now what we need to do is, looking at the other 4 cells in our matrix that we had initially, this is the transformation matrix that we're going to perform on this set of coordinates here. Now luckily we've chosen the identity matrix here, so the maths shouldn't be too difficult, it's just the same matrix reappear. So what we can tell then is that this red coordinate here, minus 1, 0, is going to be rotated to this coordinate here. Okay, so it's going to appear down here. Root 3 over 2 minus a half, so down there. This is the matrix N that's doing this. This is our matrix N here. And the next coordinate, the blue coordinate, is going to be at half root 3 over 2. So it doesn't look like it's rotated by much. It's gone from here to about here. So it's either going to be 30 degrees, 45 degrees, or 60 degrees. Let's get a little triangle out so we can tell. Let's just work with this red coordinate down here. It's got a x-axis dimension of root 3 over 2. It's going down by a half. So let's do a little bit of tan angles on this. So it's tan minus 1 of opposite over adjacent. So it's a half over root 3 over 2. That's 1 over root 3. And that's 30 degrees. So we know that this angle of rotation here is going to be 30 degrees. So the angle of rotation here is 30 degrees, and it's going to be anti-clockwise going to the left. Okay. So that's how we do these problems here. We imagine we're a little person standing next to the letter of the axis that we're rotating around. We look back at our diagram and visualize the problem now just with 2 dimensions. In this case here, we've got x on the left and z going vertically upwards. Start with your base coordinates. Perform the matrix transformation from the 4 remaining cells in your matrix once you've crossed out 5 of them. You should get the same matrix reappear again because you're transforming the identity matrix, which doesn't affect anything in your coordinates. Plot those on a different diagram and visualize the transformation that's just happened. And then you can get your answer from there. Okay, so feel free to go and rewind this video and have a look at how that was done again, but that's how we do these sorts of questions, and it's a good way of doing them as well. Now it's just time to transform the coordinates, so multiplying out your brackets, it does get quite fiddly with all these root 3's and negatives and fractions. You do get this answer though, 1 minus root 3 over 2 minus 2, 1 plus root 3 over 2. Notice here how the y coordinate has not changed at all. Given that we are rotating around the y-axis, you wouldn't expect that to change. Right then, your turn to have a go at these 2 questions here then. Pause the video and try these out. Alright then, so let's go through these questions here then. So find the matrix that represents the rotation of 90 degrees anti-clockwise around the x-axis. Now let's just draw out our axes. So we're going to have x-axis coming down this way, y-axis going in that way, z-axis going up this way. And we want to rotate around the x-axis. So we're going to imagine we're a little person looking at the y-z axes, and we see that the y-axis is on the right, the z-axis is going upwards. We'll draw this out a couple of times. Z and y. We'll start with our base coordinates of 1, 0 and 0, 1. And we will perform the 90-degree anti-clockwise rotation. So this z coordinate has now moved around to here. So now this is at -1, 0. This is our b coordinate, we can call it. So this is b prime. And that y axis has now rotated round onto the top here, so it's now 0, 1, the other way around, 0, 1, and that's our a prime coordinate. Okay, so what we've got here is a matrix that takes the 1, 0, 0, 1 coordinate to the set of coordinates. Now A is the first one we have to write in, then B is the second one we have to write in. So it's this set of coordinates here. This is our final position. So to work out M, well, what would be our transformation matrix? Well, given that we're just timesing our transformation matrix by the identity, we can kind of delete this, and we get this answer here, 0, -1, 1, 0. So this here now is the transformation matrix that rotates 90 degrees anti-clockwise around the x-axis. But our final answer here is going to be a 3 by 3 matrix. Now it's going to be 1s and 0s in the x positions. And then the rest of these 4 cells will be made up from this matrix that we calculated as M. So these 4 cells here are the matrix M, and the rest of the cells is just a 1 in the XX position and a 0s in all the other positions. Okay, let's have a go at this other tricky one here to do with rotating around the y-axis. Now, let's look back at this diagram here. We're now no longer standing at the x label, we're now standing at the y label. And remember earlier that the y1 is the difficult one. It will have the x-axis appear on the left, and it will have the z-axis appearing above. Okay, so z-axis above, x-axis to the left, and we start with coordinates of 1, 0 and 0, 1. And remember, it does feel a bit strange to have 1, 0 being on the left, but that's just how it is. And we're looking to rotate this 150 degrees clockwise around the y-axis. So I know that my final answer is going to have a bunch of 0s and 1s here. We need to just work out what's going to be here, 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 and here. So let's perform this rotation now. So the first coordinate, rotating 150 degrees clockwise round, and that's going to be nearly 180 degrees. It's going to be around here. This is going to be our A prime coordinate. Where's it going to appear? Well, it's now going to have a negative x coordinate, and it's definitely going to be more than a half. It's rotated more than halfway round, so it's probably going to be √3/2. You could calculate this with a bit of trigonometry if you wanted to. And their z coordinate is going to be positive a half because it's still going upwards. The z coordinate here is going to rotate round to be down here. This is where b prime is going to go. It's going to have an x coordinate of -1/2 and a z coordinate of -√3/2. So this matrix M that has transformed the set of coordinates 1, 0, 0, 1 has sent our coordinates to, putting A prime in first, √3/2 1/2, and the second coordinate second, 1/2 minus √3/2. Okay, and given that we're just timesing by the identity here, we can kind of just scribble this out. So our transformation matrix M is this value here. Okay, these are our 4 cells that will rotate 150 degrees around the XZ dimensions. So now all we need to do is replace, we'll fill in the zeros and ones first. It's zeros and ones that look like this because we rotated around the y-axis, and we fill in the rest of the gaps around these values here from the matrix that we've just found. So 1 over 2 and minus root 3 over 2 go in the cells like this. Okay, so that's the answer to this question here. So this is 150 degrees clockwise rotation around the y-axis. This is our matrix. Okay, so let's have a go at this couple of questions now. These are still rotation matrices. This almost looks like a reflection matrix, but it would be in the leading diagonal where all the ones are, and one of them will be a negative depending on which axis flipped. Okay, so have a go at finding out the types of transformations for these matrices here. Okay, so let's have a go at the first question here then. So I can identify that on the y-axis, this case, it's just zeros and ones, as I would expect there to be no change in the y-axis dimension. Okay, so here we're going to be working in the XZ plane. Now we remembered from just a second ago that it's X to the left, Z going upwards. How do we identify that? We identify that because if we are a little person standing at the Y label, then that's what we see. We start off with the coordinates of 1, 0 and 0, 1. And to these set of coordinates, we apply, if we're applying a transformation, we apply it at the front, and it's going to be the 0, minus 1, 1, 0 set of transformations. So this is now going to end up at, well, given that this is just the identity, we can kind of just delete it. So it's 0, minus 1, 1, 0. So where are these coordinates now? 0, 1 is going to be up here. This is our A prime coordinate now. And minus 1, 0. Minus 1 on the x-axis is now on the right-hand side. So this is where B prime is going to be. So A started here, B started here. So this is obviously a rotation around the y-axis because we deleted the y-axis initially in our matrix above, and it's gone around 90 degrees. And is that clockwise or anti-clockwise? I think it's clockwise. Okay, so that's the answer to this question here. The second question here, we can clearly see it's the z-axis that we need to delete there. So the z-axis, if we've just got the x and the y-axis remaining, it's your standard x-y axis like you've always known it. X going to the vertically upwards, so y going vertically upwards, x going across. And we start with our basic coordinates of 1, 0 and 0, 1. And to this coordinate here, we've got this matrix that transforms it. The matrix that's going to be transforming it is the 4 remaining cells in our matrix up here. So minus a half, root 3 over 2, minus root 3 over 2, minus a half. And we're going to be performing that matrix, that transformation to this set of coordinates here. And given that that's just the identity, we're effectively back at the transformation matrix. So now we just need to plot these coordinates. So this A coordinate here is now going to end up at the first coordinate set here. So it's minus a half, root 3 over 2, so higher up here. A useful point to remember is that root 3 over 2 is more than a half, so I've gone across a half and I've had to go up more because root 3 over 2 is more than a half. And the second coordinate B is going to rotate around, sorry, I've put this in the wrong position, haven't I? It's minus a half minus root 3 over 2, so it should be down here, my apologies. The second coordinate is going to end up at root 3 over 2 minus a half, so down here. Okay, so my B coordinate has rotated round to here, my A coordinate has rotated round to here. I can clearly see that there is more distance going downwards than to the left, so I'm going to just assume here that that's 30 degrees. You could calculate it by a bit of trigonometry, but I know it's not 45 degrees because it would be the same. I know that the stretch going downwards is more than the stretch going to the left, so it's going to be 30 degrees. But it's not a whole 30 degrees because I've also had to rotate around 90 degrees as well. So in this case here, the answer to what this transformation is it's a rotation around the z-axis by 120 degrees, and this time it was clockwise again. Okay, so that's how we can answer these questions here then. So I hope you've understood that. Please feel free to go and rewind the video, watch it again, watch out for certain points where we change the question from a 3-dimension question to a 2-dimension question, and have lots of practice. The more you practice, the better you're going to get, and the more you'll develop this skill. Thanks for watching.